What's up, everyone? Welcome to my YouTube channel. So, this is a system design video, and I am doing this after a long time. I know I was going to make one video every week, but I got a little busy with other stuff. So, I am back now, and today we are going to discuss different load balancing algorithms, right? So, we'll start with the easiest one. The first one is least connection method. As the name suggests, if a server has less number of connections compared to other server, then that request goes to that server. So we can see like this. Look, first client. If oops, this thickness is a lot. Let me. Oopsie. Yeah. Okay. Cool. Okay, so if this is one request number one, so it is going to server one, right? If the client request number two, it goes to this, and client three is here. So this is the already the connections that we see that have established. Now what if a new client comes in and hits the load balancer? So by this method of least connection, it will basically redirect the connection to this server as it has the least number of connections because it doesn't have any connections in this case, right? So this is a very simplest algorithm, and as the name suggests, we just connect or we just redirect the request to the server which has least number of connections. Moving forward, we will go with the least response time method. So what this algorithm takes into consideration is it will require some metrics before we can establish this algorithm. But what it does is, let's say server one, the first server, basically the first request takes, let's say, 10 milliseconds, and this request takes 30 milliseconds, right? So what is the average of the number of requests that this server takes to respond back? That is will be 10 plus 30 divided by 2, which will be 20 milliseconds, right? Correct. Now for this server, this request here is 50 milliseconds, let's say, right? So the average right now for this server is 50 because it only has got one request. Obviously I have scaled down the number of requests. This is not a real use case scenario, but just for understanding purposes. So if the new client comes in like this, the load balancer sees whichever server is taking least response time to reply back to their client, it will redirect the request to that server for now. So right now at this moment, we see that server one has the least average response time, and that's why it basically redirects the request to this server. Even though the server one has more number of connections, it doesn't take into consideration the number of connections a server has. It just takes into consideration the average response time a server takes to respond back, right? And that's how the load balancer redirects the request. This is the second algorithm. Now the third algorithm is on the bandwidth, right? Now for the bandwidth, it will be something like this. Let's say the server one, for this request, it took like the speed, maybe it's uploading a file or maybe it's downloading a file, whatever it is. I'm just taking a dummy number. It's 10 mbps, right? This bandwidth. And then for the second request is again 300, right? So the average comes down to 200. And similarly for this server, let's say it was 150 mbps. So when the new client comes in, this load balancer sees that okay, whichever has the least bandwidth, let's redirect to that server because that server has less load. Less bandwidth means less load, right? So it will redirect to this server in our case, and that's how this algorithm works. Moving forward to our round robin method. So round robin method, as the name suggests, we can think of it like a circular, or let me actually not take it as a circular. Let's take it in this format. Let's say I have two servers. In our case, it's one and two, right? So let's say the first request goes to the first server, the second request goes to the second server, the third request goes to the first server again, Now when the fourth request comes in, the round robin redirects to this server, right? So it's by pattern that, okay, what we don't care about whether the server is loaded. Let's say one of these requests is about uploading, or maybe it's heavy data heavy request, right? So it's taking a lot of time, it's taking a lot of load on that server, but our load balancer doesn't care about it. It just uses round robin to redirect the request as they come in. Like, okay, if the last time it was number 2, let's redirect this time to the next number, whichever is in the queue, right? So that's how the round robin works. um, Weighted round robin method, this is an interesting method. So in this method, what it does is, every server, obviously sometimes we can use EC2 instance, right, AWS instance as our servers. So someone, first time, if I am making a new microservice, let's say one of my servers has the capacity, let's say I give them a capacity that it can handle. I'm taking a small number for now. It can handle, let's say, 10 requests per second, right? And the second server can only take 5 requests per second, right? So what it does is, this load balance, and let me take one more server, maybe it will be easier. So we have one more server, and let's say this server has 15 requests per second capacity, that it can handle this many requests, right? Now what happens is, I don't have enough clients in this diagram, but what happens is, let's say I get 6 requests in total. So in weighted round robin, obviously round robin is involved, so I will go in a circular fashion. That, okay, the first request goes to this server, the second request goes to this server, the third request goes to this server. But the way it decides which will be the first server is based on the weights, and the weights is given by this, the values that I just used here, right? That is the number of requests per second that server can handle. So let's say we had, I will actually go on this side, yeah, and it will be easy. So let's say I had the server values as 15, 10, 5, right? So the weighted will be, let's say, 15 by 30 in this case, which will be 1 by 2. Similarly here, 10 by 30 will be 1 by 3, and here it will be 1 by 6, right? So these are the weights ratio for each server. Now if I get like, let's say 12 requests in total, so because the first server, the number 3, which has 15 requests per second capacity, and it can handle half of the requests, so 6 requests will go to the server, this server, which has 15. Similarly, 1 by 3 will be what? 12 by 3 will be 4 requests will go to this server, and then 1 by 6, that is 12 by 6, will be 2 requests will go to this server, and if you total this, it will be 12. And you can do this with any number, and you can see it will work. So in overall, I just use the simple numbers so that it's divisible, and just to make you understand. But the thing that is happening here is, based on the weights of each server, I decide where should I redirect my request. So that the server with the maximum request will get the first that many requests which it can handle, and then the next server in the line will get the request. So that's how the weighted round robin method works, right? Now we go to IP hash method. It's a very interesting method. I will go a little bit on the right to explain. So in IP hash, what happens is, we basically take our client IP, we take our server IP, right? We somehow, let's say, concatenate them. I'm just using the concatenation just to explain. So I take that and I pass it to a hash function. Now this hash function gives me a value, right? And based on this value, I connect that client to that server. So what happens is, why this is useful, like the client IP plus server's IP hash, and this value, obviously this value will stay the same because my server's IP are static, like they stay the same once I boot up EC2 instance, let's say. and my client IP, let's say if I'm using if I'm working from home, my IP will stay the same, right? So client IP and server's IP combination of hash will give me a constant value, and based on this value I can see, I can assign a server to it. Like let's say this value means server 1, this value means server 2. So in a way what happens is, by chance, let's say this client, the first client request was going to this server, right? By chance this request got cancelled, right? Like connections, it disconnects and the server is not able to serve it. Now when the client comes back, or maybe server comes back if server is down, it will again do the hash of client IP plus server IP, and it will get the same value and it will connect it back to the same server in a way. So this is sometimes useful in only those use cases where you need this client to stay connected or just send the response to that only one server all the time. I cannot think of any current live use case where we should use this load balancing algorithm, because I don't personally don't find it right, that efficient. But there are use cases and there are special use cases in where this IP hash method can be used. But it's this straightforward way where we can take combination of client IP and server. If we take a hash, we'll get a constant value, and based on that value we'll connect it to a server. This is one thing. Yeah, now coming back to our load balancing methods, till now I think we saw 6 methods. This is the last method, and this is a very important method, and I think many of the companies use this, which is consistent hashing. Now in consistent hashing what happens is, let's say we have a circular, I will explain this quickly. So we have a circular round robin thing. So I have S1, S2, S3, S4, right? So let's say I would like to say like this, because it's a circle. Obviously circle, the this part, this part starts with 0 degree and it ends with 360 degree, right? So there is, a circle has a 360 degree angle, right? So what I can do here is, I can have a hash function, and that hash function will basically take in the value. Let's say it takes the IP value or any value, we don't care about whatever value it takes, it gives us a hash. And what I do with that hash is, if I do a modulus of 360 on that hash, so whatever hash value I get, let me remove this and write it here clearly. Yeah, so if I take a hash, oops, I don't want to use this. Yeah, if I take a hash of whatever, some IP, let's take IP, and I do a modulus of 360, it will give me some value, right? It will give me, let's say it gives me 20. So what I do, 20 degree, let's say, gets mapped here somewhere. I will do with red. 20 degree gets mapped here. So in this case what I do, whichever server is on the right of this angle, let's say server 2, so this request will be resolved by server 2. So this is the area that server 2 takes care of it. Let's say I get a angle after this hash modulus, I get an angle here. Let me show it by red. Yeah, here. So what I will do in this case, I will pass it to server 4. So this area is server 4, and similarly I can do this in a round robin. It's not round robin, it's in a circular fashion. So based on the hash value I figure out the area. So this is one area for S3, this is the area for S4. Any angle here will go to S1 and here will go to S2. This is how we do consistent hashing in general. You can use any format. I am just explaining it in an angular format because it's easy for me to find a value of angle on a circle, right? And if, what is the benefit of this case, let's say server 3 goes down, I just cross it down, I'll move the screen a little bit here. Yeah, if it goes down, what will happen, this whole area now is, I'll do it by green, this whole area is now part of S4, right? This is taken care by S4, something like that. So even though any server goes down, I don't care about reprogramming my load balancer algorithm, because consistent hashing will automatically take that into consideration. This was obviously in a very overview or brief way, but I wanted to make you guys understand a simple in a simple way what algorithms we have for load balancers. And obviously we have Google, and now you can research more about it. But yeah, that's all for today's video. I hope I have kept it short. If you guys like this video, please subscribe to my channel, give me a thumbs up, and follow me on Instagram. Thanks everyone for the support. Thanks again.